For the reaction NO2 plus CO goes to NO plus CO2, we're given the rate law, which is second order with respect to NO2. We're asked to propose reaction mechanism. And in order to propose a successful reaction mechanism, it has to agree with these two criteria. The first criteria being that it must agree with the experimentally determined rate law, and the second one being the sum of the elementary steps must equal the overall balanced equation. And for simplicity of this question, I'm going to assume that this occurs in two steps for a question. Okay. Keep in mind that it has to equal the overall equation, which is NO2 plus CO, which goes to NO plus CO2. And since in second order with respect to NO2, it's reasonable to think that there's two NO2 molecules for the rate determining step or the slow step. It's NO2 plus NO2. But notice how there's only one NO2 molecule in the overall equation. That suggests that we have to cancel out one of the NO2 molecules. We can do that by adding an NO2 over here. So now you have to think of CO and CO2. Well, for CO, it's only on the step 2 because for the rate law, there's no CO or CO2 given. So we can think that CO is over here and that CO2 has to be over here. Next, for NO, we can put on the first step because it's a part of the rate determining step. So we can add NO over here. The last step we have to do is make sure that each of the elementary steps are balanced. So there's two N's over here and there's 4 oxygens. However, here we only have 1 oxygen and 1 nitrogen. That means we can add an NO3 over here to balance the equation. And since we add an NO3 over here, we can add an NO3 over here as well, so that the overall equation here balances out as well. And the NO3 would act as a reactive intermediate, which means that's generated and then consumed. And so reactive intermediates are not shown in the overall equation. And that's the answer for opposing reaction mechanism.